Question 7. Lactose is the main sugar in milk and is hydrolyzed from the enzyme by the enzyme lactase. Lactase is essential to newborn mammals as milk is their only source of food. Most mammals stop producing lactase when they start feeding on other food sources. Humans are an exception to this because some continue to produce lactase as adults. The ability to continue to produce lactase is known as lactase persistence, LP, and is controlled by a dominant allele. A number of hypotheses based on different selection pressures have been put forward to explain LP in humans. One hypothesis for LP in humans suggests that selective pressure was related to some human populations farming cattle as a source of milk. Describe how farming cattle as a source of milk could have led to an increase in the LP. So the idea that the LP or the lactase persistence has occurred due to a mutation or the allele has occurred due to a mutation. Then milk provides certain nutrients, so they will accept glucose, galactose or protein. And individuals that contain the LP are more likely to survive and reproduce, or those with the advantageous allele are more likely to survive and reproduce. Therefore, you get directional selection, and that's because the frequency of the allele is going to increase within the next generation or increase within the offspring. So the idea that the mutation will have occurred at first, but that mutation was advantageous because that milk could provide more nutrients such as glucose or protein, then the individuals that had this LP were more likely to survive and reproduce. Therefore, they would pass that allele on to the next generation and the frequency of that allele would then increase. And this is directional selection.